So in chapter 5.5, we'll be solving quadratic equations using the zero product property. So far we've solved linear equations, which are degree 1 polynomials. Quadratic equations are going to be degree 2 polynomials. So a quadratic equation is going to look something like this. ax squared plus bx plus c. So if it's completely expanded out and we combine like terms and get everything on one side, that's what it would look like, where a, b, and c are real numbers. So there's a couple different ways that we're going to be solving these. So we're looking for the x values that make these true. We can solve these in these ways down here by factoring or using the square root property, completing the square or quadratic formula. So this section we'll be doing it by factoring, and then we'll use that zero product property. So we won't always be able to factor quadratics, but if we can factor it, then we'll factor it like we've done previously and use this property that we'll go over right now. So this zero product principle or zero product property essentially says that if two or more things are being multiplied together and they equal 0, that means one of those things has to equal 0. So that's what this says right here. If x times y equals 0, then either x equals 0 or y equals 0, which hopefully makes sense. The only way to multiply factors and have it equal 0 is if one of those things is 0. So the steps for solving a quadratic by factoring, you want to rewrite it so everything is on one side of the equation and it's set equal to 0. All like terms are combined. Then we're going to factor the quadratic. So remember, factoring, we can factor, always try GCF factoring first. And then if you can't factor out a GCF, see if you can factor the quadratic trinomial. Then we're going to apply the zero product principle by setting each factor equal to 0 separately. And then we're going to solve the resulting equations. So when we have a quadratic, we should have up to 2 different equations that we'll have to solve when we set the factors equal to 0. And then we can always check the solutions back in the original to make sure it works. So let's do some examples. So the first one here, solve this by factoring. So it's x minus 1 times x plus 3 equals 0. So this is actually already factored. So we don't need to factor because it's already factored. So we're going to set each factor equal to 0 separately. So what we can do, which I'll kind of use this notation, this setup, we can create a little t like this and say if that times that equals 0, then either that first factor equals 0 or that second factor equals 0. So now we solve these separately. These are two pretty simple linear equations now. So on the left side, we add 1 to both sides and get x equals 1. On the right side, we subtract 3 on both sides and get x equals negative 3. So we could check these by plugging them back in. We would plug them back in the original, and we would see that that does equal 0 when we plug it in. So I'm going to write this as a solution set. I'm going to say x equals negative 3 and x equals 1. So I'm just using the squiggly brackets to represent a solution set. Okay, and then for the next one, x squared minus 7x plus 10 equals 0. So we can factor this by setting it up as x plus or minus something times x plus or minus something equals 0. So we need two numbers that multiply to 10 that add to negative 7. So that's going to be negative 5 and negative 2. So once it's factored, we can set it up like this and say that means either x minus 5 has to equal 0 or x minus 2 has to equal 0. We solve them both separately. On the left-hand side, we add 5, we get x equals 5. On the right-hand side, we add 2 and get x equals 2. So our answer as a solution set is going to be 2 and 5. Okay, and then for the next one, x squared minus 6x plus 9 equals 0. Once again, this is already set equal to 0, so we can just factor it. So two numbers that multiply to 9 that add to negative 6. That will be negative 3 and negative 3. So we get x minus 3 times x minus 3 when we factor it. We set both of these equal to 0 separately. And then obviously when we solve them both, we're going to get 3. So when we write our answer, we just need to write the 3 once, and that would be our solution. So only one solution for this one. Okay, next one. We have x squared plus 15x equals negative 54. So this time we have to add 54 to both sides. We want to get this set equal to 0. So adding 54, we get x squared plus 15x plus 54 equals 0. And factoring this now, we're going to think of two numbers that multiply to 54 that add to 15. And that's going to be 9 and 6. So x plus 9 times x plus 6. And we set it up using the zero product property. So if the product of those equals 0, then either those two linear factors also, one of those has to equal 0. So we solve these separately, subtract 9 on both sides, we get x equals negative 9. Subtract 6 on both sides, we get x equals negative 6. So our solution set, our two answers are going to be x equals negative 9 and x equals negative 6. And the next one, we have 4x squared minus 2x equals 0. So it's already set equal to 0, so we are good. So this time we don't have that constant term, right? We only have an x squared term and an x term. So try doing a GCF first here. There is a GCF of 2x, so we're going to factor that out. And we're going to be left with 2x minus 1 after we divide out that GCF. So now we have 2x times 2x minus 1 equals 0. So we set this up as either 2x equals 0 or 2x minus 1 equals 0. So zero product property. On the left-hand side, we divide 2 on both sides. That gives us x equals 0 divided by 2, which is x equals 0. And on the right-hand side here, we're going to add 1 on both sides. So we get 2x equals 1. Divide both sides by 2, we get x equals 1/2. So our solution set is going to be x equals 0 and x equals 1/2. Okay, and now for the next one, we'll do like 2 more or 3 more. Okay, so we're going to get everything on the same side of the equation so it's set equal to 0. So I'm going to get 0 on the left here. So I'm going to add 2x squared to both sides, and I'm going to add 7x to both sides. So that will give us 2x squared plus 7x minus 4. And I'm just going to rewrite this in the opposite direction. I'm going to write this on the left. It doesn't matter at all what side you have it on, but just so it looks the same as the other ones, I'll write it on the left. So now we can try to factor this. So what we would have to do for this one would be by grouping. So we have to think back to how we did this. So what we did is we split up that middle term. We said, instead of 7x, we're going to say it is something else x. So I'll put a blank, plus something else x minus 4 equals 0. So we have to figure out what those two values are using the first coefficient on the x squared term and the coefficient or the constant term. We have to multiply those together. So that equals negative 8. So the two numbers we pick have to multiply to negative 8. And they also have to, so I'm just going to put a times c. They also have to add to the term that we chopped up, which was 7. So two numbers that multiply to negative 8 that add to 7 are 8, positive 8, and negative 1. So I'm going to rewrite this so it looks a little better now. So that's 2x squared plus 8x minus x minus 4 equals 0. And now we do this by grouping. So we're going to group the first two terms together. And then plus, we group the last two terms together. And now grouping, the GCF of the first group is 2x. We're left with x plus 4. We factor out a negative 1 from the second group. We're left with x plus 4. And now we can factor that by factoring out the x plus 4. And we're left with 2x minus 1. So we just factored this, x plus 4 times 2x minus 1. And now we can set this up by setting them both equal to 0 separately. So that's going to be x plus 4 equals 0, or 2x minus 1 equals 0. So solving these both for x separately, we're going to get x equals negative 4. And add 1 on this side, divide by 2, we get x equals 1/2. So that's our solution set. We get negative 4 and positive 1/2. Okay, and next one. So we're pretty much just going over every kind of form that you could see this in. So now we have x times x minus 1 equals 2. So for this one, I wanted to make sure that we didn't just set x equal to 2 and x minus 1 equal to 2 and solve it. We can always use that property when it's set equal to 0. So that's why it's called the zero product property. So for this one, what we have to do is we have to distribute the x. So we get x squared minus x equals 2. Then we want to get everything on one side set equal to 0. We get x squared minus x, subtract 2 on both sides, so minus 2 equals 0. And then we can factor this just like we've been doing. Two numbers that multiply to negative 2 that also add to negative 1 are going to be negative 2 and positive 1. So x minus 2 times x plus 1 equals 0, zero product property. That means either this factor has to equal 0 or this factor has to equal 0. We solve them both separately. And we get, add 2 on both sides, we get x equals 2. Subtract 1 on both sides, x equals negative 1. So those are our answers, our solution set. X equals negative 1 and x equals 2. Okay, so I think this is the last one here. So kind of nastier, we have x plus 3 squared equals 2 times 9x minus 5 minus 1. So it doesn't look like the other ones necessarily, but it's going to be the same procedure. We're going to get everything on one side and get it set equal to 0, but first we have to simplify each side here. So x plus 3 squared is x plus 3 times x plus 3. We would have to FOIL that out. We would get x squared plus 6x plus 9. And on the right side, we have to distribute the 2. We're going to get 18x minus 10 minus that 1. So I'm just going to rewrite this left-hand side, and I'm going to combine like terms on the right. Negative 10 minus 1, we get negative 11. So now we have to add the 11 to both sides and subtract 18x on both sides. So if we subtract 18x, we're going to get x squared plus the 6x minus 18x. That gives us negative 12x. 9 plus 11 is plus the 20, and now it's set equal to 0. Okay, so now we want to factor that. So like I mentioned, not everything will be able to be factored, not every quadratic. Obviously, they were all able to be factored for this particular section. So when we factor this now, we're going to think of two numbers that multiply to 20, that add to negative 12. Those are going to be negative 10 and negative 2. So we get x minus 10 times x minus 2. So hopefully we can do most of this in our head by now once we get to this step. We set each factor equal to 0. That's x minus 10 equals 0. And x minus 2 equals 0. Solve them separately. We get x equals 10 and x equals 2. So those are our answers for our solution set, x equals 2 and x equals 10. Okay, so that is it for this first section, and we'll continue doing the other methods in the future.